Hello, ladies and gentlemen. We're going to do 5.7 today. It is the fundamental theorem of algebra. We are going to find all of the zeros of a polynomial function. We're going to talk about multiplicity and repeated zeros again. And then we're going to talk about factoring and complex zeros. And then we're going to write the complete linear factorization. All right, so what I'd like to do is start right off with an example. And our example is going to be f of x is equal to x cubed plus 5x squared plus 4x plus 20. Okay, so there's a couple of things about this function that I know before I even start. I know what the end behavior looks like. It's going to be down and up. Okay, so I know that my end behavior is going to be down and up because it's a cubic function. Okay, I know that I'm supposed to have 3 zeros because it's a third degree polynomial, which means that it should have 3 x-intercepts because zeros and x-intercepts are basically the same word. All right, so what I'm going to do is I'm going to graph my handy-dandy function in my grapher. And so I'm going to graph our x cubed, and then I have plus 5x squared, and then 4x, and then 20, making sure that I entered it correctly, and I'm going to do a zoom 6. Alrighty, so if you'll notice, we really only see 1 0, and I could change my zoom window, and I'll do that in a bit, but I really don't see what I expected to see. So even if I do a second calculate, and I find my 0, and I'm going to look for the left. I think you can still see. So I'm going to look for my left 0. There it comes. And I often watch this bottom bar down here, kind of paying attention to where I am on the coordinate system to help me get in the right place. So there's my left bound. I'm going to hit enter. And then I'm going to go to the right, enter, enter. And we found that at 1x that we can see is a -5. But there are two more zeros that are missing. So now my task is to find those. So the first thing that I'm going to do is I'm going to change my zoom window. So I'm going to do a zoom 0 for a zoom fit. So zoom 0 is a handy zoom option. And notice that my graph still looks to be about the same. So I'm going to attempt the same process. So I'm going to do a second calculate 0. And I'm going to go way to the left just to make sure that something's not going on in the middle that I can't see. So now I'm to the left, and I'm going to hit enter. And then I'm going to cruise around. Let me move my calculator up a little bit so you can see it better. I'm going to go way to the right, okay, just to make sure that I'm not missing anything. I'm going to get up above the x-axis, enter, enter. And notice that my 0 is still x is equal to a -5. So that hasn't changed. So that means the 2 zeros are hiding. Okay? Alrighty. So I'm going to do synthetic division to help me find the 2 missing zeros. So I'm going to divide by a -5. I don't need any placeholders, so I'm going to have 1, 5, 4, and 20. Bring down the first term, and I get a -5, 0, 0, 4, -20, 0. So this is actually a really important piece of information. If a number, and we found it on our grapher, it was a -5, is an actual 0, then the remainder will be 0. So if you don't get a 0, that means either you did your synthetic division incorrectly, or it's actually not a 0, and so you need to verify both. Sorry. This is a third degree, so that means that my solution line or my quotient line is a second degree. So this is x squared, there's no 0, there's no x term, and then plus 4. And I want to find the 2 missing zeros because this is a second degree. This is where my 2 zeros live. So I'm going to get x squared is equal to a -4 take the square root of both sides and I get x is equal to plus or minus 2I. So let's talk about what that does to our graph. And I'm going to go back to my, ooh, that's a really bad glare. I'm going to go back to my Zoom 6. So we had two zeros and it never recrossed the x-axis. So because they are imaginary, they will never cross the x-axis. So imaginary numbers are not x-intercepts. Alrighty, so that's kind of our information that we're going to have about this particular graph. So now what I want to do is talk about graphs in general. Okay, so if I have a graph, and let's say my graph did something like this. If you'll notice, it goes from one side of the x-axis to the other side. This would be the negative side. This would be a positive side. There's a sign change in the y values, which means that that particular point is going to have a multiplicity. And remember, that is a repeated zero that's odd. And in this particular case, this was a -5 with a multiplicity of 1. And 1 is an odd number. Okay? We couldn't see our two imaginary solutions because I don't cross the x-axis. But let's say my graph did something like this. Okay? Except my pen skipped. This is what I call a through and through. That means that this has an odd multiplicity. Okay? I'm just going to write odd mult instead of multiplicity. This right here kisses the x-axis, and so that has an even multiplicity. Okay, that means this could be a 2 with a multiplicity of 2, or it could be a 2 with a multiplicity of 4. So if the multiplicity is even, then the graph is going to kiss the x-axis. So it actually allows us to graph a function without using a grapher because we know a lot of characteristics. All right, so let's move on and do another example. So this time, I'm going to do a slightly higher degree polynomial. I'm going to have f of x is equal to x to the 4th minus 8x cubed plus 18x squared minus 27. And I am going to graph that. So we are trying to find all being the key word, meaning that the zeros could be real or the zeros could be imaginary. So I'm going to put this into my grapher. So I'm going to enter x to the 4th minus 8x to the 3rd plus 18x squared minus 27. I'm going to check and make sure I didn't screw anything up. And then I'm going to hit graph. And I'm going to do a Zoom 6 because I don't remember what window was on for the last graph. Alrighty. So this is a 4th degree polynomial, which means that its end behavior is up and up because basically it's a glorified parabola. Okay? Which means that I'm also, scoot this little guy over, sorry the glare is so bad, I'm supposed to have 4 solutions. Remember, that also means I'm supposed to have 4 zeros because those words are used interchangeably. But in my graph, I only see 2. So what I'm going to do is I'm going to find those 2 zeros before I do anything else. So I'm going to do second calculate 0. And I'm going to find my, oops, I passed it, my left one first. So there's my left 0. And then I go on the other side of the x-axis, enter, enter. And I know that my first x-intercept is a -1. When I do my graphs, I always do mine in the same basic procedure. And so I always do my leftmost zeros first. And then I go over and do my right ones. So now I'm going to do the right one. Second calculate 0. I need to get to the left, watching your calculator carefully. Oh, there it comes. Get a little bit closer, enter. And then I just need to cross the x-axis, enter, enter. And I get that that's 2.9999053, so we're going to round that to 3 because that makes our math significantly easier. All right, so now I'm kind of done with my calculator, so I'm going to move it off to the side. I needed to find 4 zeros, and I only know 2. So that means 2 are hiding. So I'm going to do something, I don't know that it's a very technical term, but I call it nested synthetic division. So basically what I'm going to do is I'm going to do synthetic division a couple of times with the 2 zeros that I know, and then that will get me down to a point where I can find my 2 other missing zeros. Notice that I'm missing the x term, so I want to be careful and put my placeholder in. It doesn't matter which 0 you start with, so I'm just going to start with the -1 because that's the one I found first. I'm going to write my coefficients. This is a 1, -8, +18, 0, -27. Bring down the first term, which is a 1, and now I'm going to start my process. So I have a -1, add -9, +9, 27, -27, -27, +27, and 0. That 0 is significant because it tells me that the -1 is actually a 0, which is nice. It just tells me I didn't screw up. Now I'm going to do synthetic division again using the second 0, and I'm going to start right on the answer line from my first set of division. So remember when we started, this was a 4th degree. That means this line is a 3rd degree. So now I'm going to bring down the 1 again, and I'm going to start doing my synthetic division again. So 3 times 1 is 3, subtract -6. -6 and 3 is a -18. Subtract, and I get 9. 3 times 9 is 27. I get a 0. Again, that's a very important 0 because it confirms that this is actually a 0. So now I'm down to a 2nd degree, which means that I can factor this to solve. So this is x squared minus 6x plus 9. This is a perfect square trinomial, so this is x minus 3 quantity squared. Well, I was missing 2 zeros. Here are my 2 other zeros. So now I have x is equal to 3 with a multiplicity of 2. But I also had a 3 up here on the top. So now if I list all of my zeros, I would say that I have x is equal to a -1 and 3 with a multiplicity of 3. So now I'm going to do the next step. I'm going to write the complete linear factorization. So you have to pay close attention to what the book is asking you to do. Sometimes they will say find all zeros, and you would just list your zeros. And then sometimes they may say write the complete factorization, and if they do, then you have to include the next step. So this would be my complete linear factorization. My factors would be x plus 1 and x minus 3 to the 3rd. And that would be the complete linear factorization for our polynomial of x to the 4th. All right, so let's get a clean sheet of paper and do our next example. Okay, a little bit higher degree this time. So I'm going to graph, first I'm going to tell you what you're supposed to do. I want you to write the complete factorization, which means I need to find all of the zeros and then write it in factored form. So my function is going to be f of x is equal to x to the 5th minus 4x to the 4th plus 4x to the 3rd plus 10x squared minus 13x minus 14. Whew, that's a big one. All right, so a couple of things that I know. This is an odd degree, so that means that my end behavior is basically down and up. Okay. I know that I'm supposed to have 5 zeros. And I'm going to graph this little puppy first. Okay, so I'm going to, go to my y equals. I'm going to enter my equation. So I have x to the 5th minus 4x to the 4th. Make sure I'm, forgot the 4. plus 4x to the third, go back to the third, and then plus 10x squared minus 13x, and then minus 14. Check to make sure I didn't mess anything up. 4x to the third, 10x squared. I think I'm good, and I'm going to graph it. And since my last one was done at a zoom 6, this one's also going to be at a zoom 6. So it's actually a pretty cool graph, so let's talk about the graph before we move on. Notice that at this point right here, it appears to have a kiss. That means that that particular 0 is going to have an even multiplicity. We don't know what it is, but we will be able to find it eventually. Okay? This point is a through and through, which means that this one's going to have an odd multiplicity. So the first thing that I'm going to do is I'm going to find my zeros. Okay? Scoot that over out of the way. And it might also be nice if we zoomed in just to make sure we know what's going on at that particular spot. So I did a zoom 2. I moved my cursor to that spot, and then I did a zoom 2. And what I was looking for was to make sure that when I got closer that there wasn't some little piece of the graph going up above the x-axis. So it's not, so it was what I thought. So now I'm going to find my zeros. Okay, second calculate. Second calculate, you have to wait for it to be done. That means you have to be patient. Okay, and I'm going to do, here's my left, and then I'm going to go to the right, enter, enter. It's thinking very hard. Notice that that 0 is negative 0.999996. We're going to round that to 1, so I'm going to have x is equal to a negative 1. I know that that's an even multiplicity, so I'm going to guess that it's a multiplicity of 2, maybe a multiplicity of 4. Okay? More than likely it's a multiplicity of 2. Okay? And then I'm going to find my other 0, 2. I could also go to my table and look at my table, but for right now I'm just going to do it graphically. Enter, enter, and I get that my next one is 2. Alright, so I'm going to do my synthetic division with the negative 1. I will probably do it twice, and then I'm going to do the negative 2. So let's now start our process of nested synthetic division. I don't need any placeholders because I have no missing terms, which is nice. And I'm going to start with the negative 1. So I'm going to start by dividing the negative 1, write down my coefficients, negative 4, positive 10, negative 13, negative 14, and I'm going to write a 5 and circle it that tells me I'm starting with a 5th degree polynomial. Alright, bring down my straight line. My first term, multiply negative 1. This is negative 5, positive 5, 9, negative 9, 1, negative 1, negative 14, positive 14, 0. This is good because this tells me that the negative 1 was actually a 0. So now what I'm going to do is I'm going to switch and do the 2. Okay, and I'll come back and get the other 1 in a minute. Draw my little line, bring down my first term, and start my process over again. So 2 times 1 is 2, negative 3, negative 6, 3, 6, 7, 14, 0. I'm on a roll. Yay, lucky me. So now I'm going to go back and pick up another one of those negative 1s, because remember we said it had a multiplicity of at least 2. Okay, so we're going to do division again. I'm going to do another negative 1. Bring down my first term right here. So I have a negative 1, negative 4, positive 4, 7, negative 7, 0. Well, that was pretty handy. Okay, so now what I'm going to do is see if I can factor this. So this was a 5th degree, this was a 4th degree, 3rd degree, 2nd degree, so that means I should be able to factor. And notice I'm keeping my math fairly neat, and I'm just doing my division with a quotient line each time. So now this is x squared minus 4x plus 7. Well, the bummer is that's not factorable, so I'm going to have to use my quadratic formula, which is x is a negative b plus or minus b squared minus 4ac all over 2a. So if I do that math, I get 4 plus or minus 16 minus 4 times A times C all over 2A. When I do that math in my calculator, I get 2 plus or minus 1.732i. Okay? Remember the I comes from, oops, I guess you can't see it. The I comes from having a negative discriminant, which means the value underneath the square root is negative, and that's when I take the square root of a negative number, I get an I when I'm done. All right, so we still need to write our factorization. So now I know that my x's are going to be a -1 with a multiplicity of 2. Then I had a 2, and then I have my 2 plus or minus 1.732i. Okay? So when I write my factors, here's my f of x. It's going to be x plus 1 squared, because it had a multiplicity of 2, x minus 2, and then it's going to be x minus, and then my factor, 2 plus 1.1732i, and then x minus the conjugate, 2 minus 1.1732i. I always want to simplify my signs, so this becomes, sorry, you can't see it again, x plus 1 squared times x minus 2, and then I'm going to have x minus 2 minus 1.1732i, and x minus 2 plus 1.1732i. Whew, that's a lot of math. So this is the complete linear factorization. It's really important to remember it's always going to be x minus and then whatever the factor turns out to be. Okay? So two negatives would make a positive, or if I had a positive x minus, and then it would show like this. All right, so now we're going to go in the opposite direction. Okay, so we're going to go in the opposite direction. All right, so let me turn the page. As we go in the opposite direction, we're getting close to being done, which is nice. Now what's going to happen is I'm going to give you the zeros. So the example is going to be, you have zeros of -1, 2, and 4. So we know that those would be the zeros, and I want you to write the polynomial in factored form, or sorry, in standard. There we go. That's a weird looking T. Sorry, we'll just scribble that out. Okay. So now I want you to write the polynomial in standard form. So just like we did earlier when we were doing quadratics, I'm going to start by writing this in factored form. So I'm going to write it as x plus 1, and then x minus 2, and then x minus 4. And we've actually done this process before, so I'm going to expand. You can do a box, okay? And I'll just do the first box over here on the right, okay? So if this is x, and this is plus 1, and x minus 2, I get x squared minus 2x plus 1x minus 2. And that piece simplifies to be x squared minus 1x minus 2. So now I get to do a box again. So here's my x squared minus 1x minus 2. Now I need to do this math, okay? And I'll do that box underneath. Okay, so here's my bigger box. My own personal idiosyncrasy is I like to put the 3 thing on the top. Just a little bit on the idiosyncratic side, sorry. X cubed minus 4x squared minus x squared plus 4x, and then minus 2x plus 8. Alrighty, we're almost done. Simplify that mess, and I get f of x is equal to x cubed minus 5x squared plus 2x plus 8, and that is my polynomial in standard form. So that wasn't so bad. All right, so now I'm going to do my next one. The next one is a little bit more unique. I'm going to have x is equal to 3, and then I'm going to have 3 minus I. Now the interesting thing about complex factors is that they always occur in conjugate pairs. So I'm going to write that down. Is our complex zeros, and I'm going to write factors beside it just so we kind of make sure we're all talking about the same thing. Complex zeros always occur in conjugate pairs. And we've talked about conjugates in the past. So even though they've only listed one of the complex zeros, I know that they are actually 3. There's the 3 minus I. It's also going to include 3 plus I. And so I'm going to do the same thing. I want to write the polynomial in standard form. Alrighty, so when I do these, it's always best to start with the complex conjugate pairs first because we want to be able to get rid of those. So I'm going to write my factorization. I have x minus 3, and then I have x minus, and I'm going to put it in parentheses just to make sure you see it, and x minus the 3 plus I. Then I'm going to simplify those signs. So here's the x minus 3. Oops, I'm sorry. There's the x minus 3. And then I have x minus 3 plus I and x minus 3 minus I. So now I'm actually ready to start doing my box. You always have to do the conjugate pair first. So I'm going to do a 3 by 3 box. Okay. All right. So here's 1, 2, 3. 1, 2, 3. Okay, and this is going to be my x minus 3 plus I and my x minus 3 minus I. All right, so if I start filling in this box, I'm going to have x squared minus 3x minus xi. Don't freak out about these. They end up canceling. A negative 3x plus 9 plus 3i. A positive xi, a negative 3i, and a negative I squared. So let's look at all the things that cancel. I have a negative xi and a positive xi. Those two go away. I have a positive 3i and a negative 3i. Those go away. And a negative I squared, remember from when we did our complex numbers, turns into a positive 1. So now I can combine like terms, and this turns out to be x squared minus 6x plus 10. Remember though that I have one more set of multiplications to do, because now I need to multiply that by the x minus 3. Notice that our i's, the problem children, disappeared, and all we have left are nice polite numbers. So now I'm going to do my box again. Okay, so here's my 3 thing, here's my 2 thing. This is x squared minus 6x plus 10. It's kind of a weird box, sorry about that. X minus 3, x to the third minus 3x squared minus 6x squared plus 18x plus 10x and then minus 30. And I'm going to go write this back up top so we make sure that we get it all in there. This is x to the third minus 9x squared plus 28x minus 30. And this, ladies and gentlemen, except it equals f of x, is a solution. So not too difficult, but a little bit tedious. Alrighty, we are actually done. Let me give you your problems for the evening. Okay. Alrighty, here are your problems. I want you to find all zeros using a combination of graphing and synthetic division. I'm just going to write division using our little division symbol. Number 1, you're going to do f of x is equal to x to the fourth minus 6x cubed plus 7x squared plus 6x minus 8. So remember, you're going to graph this first, see if you can find any real zeros, and then do synthetic division to find the zeros that are missing. Number 2, f of x is equal to x to the 4th plus 15x squared minus 16. So when you do the synthetic division, if that's necessary, make sure you remember your placeholders. The next two says write the polynomial in standard form. Alright, and you're going to be given on the first one that x is equal to a -5, a -1, and 2. And then for the last one, x is equal to 3, a 2i, and a -2i. On this one, make sure that you set up your factorization. I'm actually going to help you with that just to make sure you get it correct. It's going to be x minus 3 times x minus a positive 2i and x minus a -2i. So that would be your linear factorization for that one. And then you need to simplify your signs and then put it in standard form. All right, good luck, and I will see you tomorrow.